Okay, example 4 of Newton's laws of motion. A ball of mass 0.1 kilograms falls vertically and hits a soft muddy ground whose resistance is 1.48 newtons. Show on a diagram the forces on the ball. Okay, so we have a ball here. And the forces on the ball, we have a resistance which is going up, and that's 1.48. Okay, we have forces going down. Now, the force going down is the weight. And weight is equal to mass times gravity, which is 0.1 times 9.8, and that's going to be 0.98 newtons. So that's your downward force. Okay, and your upward force. Now, if the ball speed was 10 meters per second on impact, find the depth with which the ball will penetrate the ground. Okay, well, we have to look. We need acceleration. We need a few things. Well, let's start looking at, if we say the force is equal to mass times acceleration. Okay, let's look at the overall force with which the ball hits the ground. Okay, so the resultant force. So we have, if we remember that we always take the forces as being positive, gravity is going up, so that means this will be going down, it would be opposite of gravity. So that would be 0.98, that's the resultant force going down. And then we're going to take away from that the 1.48 newtons, and that gives us an overall force of minus 0.5 newtons. Okay, so if that's the overall force on the ball, we can use that to find out the acceleration of the ball when it hits the ground. Now we know that it starts off, the acceleration is due to gravity is 9.8 meters per second, but that's not going to be its acceleration when it hits the ground, because it's got a mass which changes it. So I can say that again, force is equal to mass times acceleration. So minus 0.5, that's the acceleration it hits the ground with, is equal to 0.1, that's 0.1 kilograms, times A. Divide both sides by 0.1, and we get that minus 5 is equal to A, and that's meters per second squared. Okay, so now what we're actually looking for here is we want a distance. Okay, what do we actually know? We know the final speed, because that's going to be 0. Okay, do we know the initial speed? Yes, we do know the initial speed. That is 10 meters per second. So U is equal to 10 meters per second. Okay, and we know that A is equal to minus 5 meters per second squared. We don't know time, we don't know anything else, so we have S, V, U, and A, so we're going to use V squared is equal to U squared plus 2AS, so 0 is equal to 10 squared plus 2 times minus 5 times S. Okay, and so 0 is equal to 100 minus 10S, so minus 100 divided by minus 10 is equal to S, so 10 meters is the depth into the ground it goes.